Right. Today we discuss exercise 3.2, 16th problem onwards. So that question is very important in the examination point of view. So that question comes in 5 marks questions. That is question number 16, exercise 3.2. If A is equal to, here given A is 1, 0, 2, 0, 2, 1, 2, 0, 3. Prove that a cube minus 6a square plus 7a plus 2i is equal to 0. So here already I is given. I is identity matrix of order 3, A is matrix A. So A square we have to find, A cube also. So first find A square. Here A square is A into A. So your matrix A is 1, 0, 2, 0, 2, 1, 2, 0, 3 into matrix, again matrix A, that is 1, 0, 2, 0, 2, 1, 2, 0, 3. So matrix multiplication. Sum of the product of first row with first column. So 1 into 1 is 1 plus 0 into 0 is 0 plus 2 2s are 4. That is the first element. Next, first row with second column. So 1 into 0 is 0 plus 0 into 2 is 0 plus 2 into 0 is 0. Next, first row with third column. So 1 into 2 is 2 plus 0 into 1 is 0 plus 2 3s are 6. Next, second row with first column. 0 into 1 is 0 plus 2 into 0 is 0 plus 1 into 2 is 2. Next, second row with the second column. 0 into 0 is 0 plus 2 2s are 4 plus 1 into 0 is 0. Second row with third column. 0 plus 2 plus 3. Next, third row with first column. 2 1s are 2 plus 0 plus 3 2s are 6. Second row with second column. So 0 plus 0 plus 0. Next, third row with the third column. 2 2s are 4 plus 0 plus 3 3s are 9. So therefore this matrix is 5, 0, 8, 2, 4, 5, 8, 0, 13. So this is matrix A square. So illige nimage 1 mark kodtare. Nimage next find A cube. Here what is A cube? A cube is equal to A square into A. So here what is A square? A square is 508. Next 245. Next 8013 into matrix A. A cube is equal to A square into A. A square already find out ಮಾಡಿ ನಾವು ಅದು substitute ಮಾಡಿದೆ into A, that is 102 021 203. Again matrix multiplication. So first element is obtained by sum of the product of first row with first column. So that is 5 1s are 5 plus 0 into 0 is 0 plus 8 2s are 16. Second row, first row with the second column, we get A12, that is 5 into 0 is 0 plus 0 into 2 is 0 plus 8 into 0 is 0. Next, first row with third column. So 5 2s are 10 plus 0 into 1 is 0 plus 8 3s are 24. Next, second row with first column. 2 1s are 2 plus 4 into 0 is 0 plus 5 2s are 10. Next, second row with the second column. So 2 into 0 0 plus 4 2s are 8 plus 5 into 0 is 0. Next, second row with third column. 2 2s are 4 plus 4 1s are 4 plus 5 3s are 15. Next, 8 1s are 8 plus 0 plus 13 2s are 26. Next, third row with the second column. 8 into 0 is 0 plus 0 into 2 is 0 plus 13 into 0 is 0. Next, third row with third column. 8 2s are 16 plus 0 plus 13 3s are 39. So that is 16 plus 5 21 0 24 plus 10 34. Next, 10 plus 2 12 8. So 19 23. Next, 26 plus 8 34 0 So 39 plus 16, so 55. So this is matrix A cube. Next, here take LHS. What we have to prove? A cube minus 6a square plus 7a plus 2i is equal to 0. So take LHS. We have all the values. I is identity matrix of order 3. A is given. A square already find. So next A cube. Also we have A cube values. A square and A cube values. Substitute A square, A cube, A, I in LHS. So take LHS. Your LHS is Your LHS is A cube minus 6a square plus 7a plus 2i. So this is LHS. Now substitute A cube. Your A cube is 2108, 21034. Next 12823, 12823. Next 34 0 55 minus 6 into A square is 508, 245 80 13 plus 7a. 7 into matrix A is given 102 102 021 and 203 plus 2 into identity matrix 100 010 001. Now simplify. That is 21 0 34 12 8 23 34 0 55 minus multiply every element of this matrix by 6. 6 5s are 30, 0 6 8s are 48, 6 2s are 12, 6 4s are 24, 6 5s are 30, 6 8s are 48, 6 0 0, 13 6s are 78 plus 7 1s are 7 plus 0, 7 2s are 14, 0, 7 2s are 14, 7 1s are 7, 7 2s are 14, 0, 7 3s are 21. Multiply every element by 2. So that is 2 0 0 0 2 0 0 0 2. So first simplify these two. So that is 21 minus 30 minus 9, 0 minus 0 0, 34 minus 48, that is 48 minus 34 6 8 14. So that is minus 14. So 12 minus 12 0. So 8 minus 24. So 8 minus 24 16. So that is minus 16. 23 minus 30 minus 7. 34 minus 48, that is minus 14. 0 minus 0 is 0. 55 minus 78, so 78 55, so that is 23. So minus 23 plus, so simplify these two. 7 plus 2 9, 0 plus 0 0, 14 plus 0 14, so 0, so that is 16. So 7 plus 0 7, so 14 plus 0 14, 0, so 21 plus 2 23. Simplify these two. Here minus 9 plus 9 0, so 0 plus 0 value 0. So minus 14 plus 14 0, so 0 plus 0 0, so minus 16 plus 16 value 0. So minus 7 plus 7 0, so minus 14 plus 14 0, 0 plus 0 is 0, minus 23 plus 23 value is 0. So this is the null matrix of order 3. So it is denoted by, so capital O. So therefore clearly A cube minus 6a square plus 7a plus 2i value is 0. So therefore, so this is RHS. So this is the proof of 16th question. 17th also same type question. So let us see 18th question. Right, question number 18. Question number 18, if a is equal to 0 minus tan alpha by 2, tan alpha by 2 0, and I is the identity matrix of order 2, show that I plus a is equal to I minus a into cos alpha minus sin alpha cos alpha. Here given 18th question. Here given matrix A is 0 minus tan alpha by 2, tan alpha by 2 0. So this is the given matrix A, and I is the identity matrix of order 2. So prove that I plus A is equal to I minus A into cos alpha minus sin alpha cos alpha. So first take LHS I plus A. Here LHS is equal to I plus A. Here I plus A, what is I? Identity matrix of order 2, that is 1 0 0 1, plus what is matrix A? 0 minus tan alpha by 2, tan alpha by 2 0. So add these two matrices, adding the corresponding elements we get the addition of two matrices. 1 minus tan alpha by 2, 0 plus tan alpha by 2, that is tan alpha by 2. So 1 plus 0 is 1. So this is LHS value. And take RHS. Here RHS is equal to I minus A into cos alpha minus sin alpha cos alpha. So this is RHS. Here LHS is equal to RHS ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು ನಾವು ಅಷ್ಟೇ. Here what is I minus A? I plus A is equal to 1 0 0 1 plus 0 minus tan alpha by 2 tan alpha by 2 0. So ಇಲ್ಲಿ minus ತಗೊಂಡ್ರೆ 1 minus 0 is 1. So 0 minus minus of minus plus tan alpha by 2. Here I minus A becomes 1 minus 0 is 1. 0 minus of minus, that is tan alpha by 2. 0 ಇಲ್ಲಿ ಮೈನಸ್ ತಗೊಂತೀವಲ್ಲ, ಮೈನಸ್ tan alpha by 2, and 1 minus 0 is 1. So this is I minus A into cos alpha minus sin alpha cos alpha. So again matrix multiplication. So that is first row with first column, sum of the product of first row with first column. So 1 into cos alpha is cos alpha plus tan alpha by 2 plus tan alpha by 2 into sin alpha. Next first row with second column, minus sin alpha into minus sin alpha plus tan alpha by 2 into tan alpha by 2 into cos alpha. Next second row with first column, minus tan alpha by 2 into cos alpha plus sin alpha. Second row with second column, minus into minus plus, so tan alpha by 2 into sin alpha plus 1 into cos alpha is cos alpha. So this is after multiplication. Next so LHS new next, so that is write in terms of sin and cos. So that is cos alpha plus tan alpha by 2 is equal to sin alpha by 2 divided by cos alpha by 2 into sin alpha. Next minus sin alpha plus tan alpha by 2 is sin alpha by 2 divided by cos alpha by 2 into cos alpha. Next second row, minus sin alpha by 2 divided by cos alpha by 2 into cos alpha plus sin alpha. So tan alpha by 2, sin alpha by 2 divided by cos alpha by 2 into sin alpha plus cos alpha. So that is taking LCM, cos alpha into cos alpha by 2 plus sin alpha by 2 whole divided by cos alpha by 2 LCM. Next again LCM is cos alpha by 2 minus sin alpha into cos alpha by 2 plus cos alpha into sin alpha by 2. In second row, minus cos alpha into sin alpha by 2 plus sin alpha into cos alpha by 2 whole divided by cos alpha by 2. Next, sin alpha into sin alpha by 2 plus cos alpha into cos alpha by 2 divided by cos alpha by 2. So we have compound angles. Cos x into cos y plus sin x into sin y is cos x minus y. Next, sin x into cos y plus cos x into sin y is sin x minus y. Using compound angles, first row becomes cos x minus y, that is alpha minus alpha by 2 divided by cos alpha by 2. Next, if you take minus outside, so that becomes sin alpha cos alpha by 2 minus cos alpha into sin alpha by 2, that is sin x minus y formula, alpha minus alpha by 2 whole divided by cos alpha by 2. Next, this is cos alpha into cos alpha by 2 minus cos alpha into sin alpha by 2, that is sin alpha minus alpha by 2 divided by cos alpha by 2. Next, this is cos x into cos y plus sin x into sin y, so that is cos x minus y formula, that is cos alpha minus alpha by 2 divided by cos alpha by 2. So that is cos alpha by 2, alpha minus alpha by 2 is alpha by 2 divided by cos alpha by 2 minus sin alpha by 2 divided by cos alpha by 2. Next, sin alpha by 2 divided by cos alpha by 2, cos alpha by 2 divided by cos alpha by 2. So after simplification, so this is 1 minus tan alpha by 2, so that is tan alpha by 2, so the 1. So clearly this is LHS. So therefore, so this is the proof of, so question number 18. So take LHS, first LHS value find out Matrices, next RHS is equal to this one, so this is same as LHS, the clearly LHS is equal to RHS. So this is the proof. Next 19th question. Question number 19. Right, so a trust fund has 30,000 rupees that must be invested in two different types of bonds. The first bond pays 5% interest per year and the second bond pays 7% interest per year. Using matrix multiplication, determine how to divide 30,000 among the two types of bonds. If the trust fund must obtain an annual total interest of 1800, first question, 2,000 rupees is the second question. Here question is, so a trust fund has 30,000, so trust want to invest 30,000 into two different types of bonds. Okay, now here first type of bond pays 5% interest per annum and second bond pays 7% interest per year. So question is, using the matrix multiplication, how to divide 30,000 among the two types of bonds if the trust fund obtain the annual interest is 1800, first question. So ಈಗ 30,000 invest into two types of bonds. So let the amount, so question number 19, let amount invested in the first type of bond. First bond is equal to x rupees. So let the amount invested in the first bond is x. What is the amount invested in the second bond? Total amount available is 30,000. So already amount invested in the first bond is x. Remaining amount is 30,000 minus x. That is the amount invested in the second bond. So that is therefore amount invested in the second bond is equal to 30,000 minus x. So this is the amount invested in the second bond. According to the problem, first question is problem. So amount invested in the first bond is x. Amount invested in the second bond is 30,000 minus x. So this is the first matrix into your interest pay. So first bond is 5%, that is 5 by 100. So interest paid, second bond is 7%, that is 7 by 100. Your total interest is 1800. Total interest is 1 year. After 1 year, total interest is 1800. That is the first question. So again matrix multiplication. So first row with first column. So that is sum of the product of first row with first column. That is x into 5 by 100 is 5x by 100 plus 30,000 minus x into 7 whole divided by 100 is equal to 1800. So therefore, so this is also one matrix, singular matrix. So it contains only one element. So your denominator is same, that is 100. So that is 5x plus 7 3s are 2,10,000 minus 7x is equal to 1800. So that is 5x minus 7x minus 2x is equal to minus 2x plus 2,10,000. 2,10,000 is equal to 1800 into 100 is 1,80,000. 1,80,000. So therefore minus 2x transpose to RHS, that is plus 2x is equal to 2,10,000 minus 1,80,000. That is, so 2x is equal to 30,000. Therefore x is equal to 15,000 rupees. 30,000 divided by 2, so you get the x value is 15,000. Therefore here what is x? Amount invested in the first bond is 15,000. Amount invested in the second bond is 30,000 minus x value 15,000. 30,000 minus 15,000 is again 15,000. Therefore, so amount invested in the two types of bonds are 15,000 and 30,000 minus x value. X is equal to 15,000. So 30,000 minus 15,000 again 15,000 respectively. So therefore amount invested in the first bond is 15,000. Amount invested in the second bond is 15,000. So we get the annual interest is 1800 rupees. So that is the question. So similarly we can find the second question, same according to the problem. So LHS is equal to 2000 rupees topic 1800 place ನೀವು 2000 ತಗೊಂಡು, so problem same method, x value find out ಮಾಡಿ. So that is the amount invested in the first bond. So 30,000 minus x is the amount invested in the second bond. So just you replace 1800 by 2000. So that is the second question. Next question number 20. The question number 20 is, the bookshop of a particular school has 10 dozen chemistry books, 8 dozen physics books, 10 dozen economics books. Their selling price are 80 rupees, 60 rupees and 40 rupees each respectively. Find the total amount the bookshop will receive from the selling all the books using matrix algebra, using matrix multiplication. So find the total amount the bookshop seller will receive. That is the question. So here two matrices are given. One is books, number of books, another one is cost price of each book. So let the matrix A is, one matrix is question number 20. Let matrix A is number of books. So 10 dozen of chemistry books, that is 10 into 1 dozen means 12 books. 10 dozen means 10 into 12 books chemistry. Next 8 dozen of physics, 8 into 12. Next 10 dozen of economics books. So these are the books, that is 10 into 12, 120 chemistry books, 96 physics books and 120 economics books. So this is one item. Okay. So number of books. Cost price is, let B is cost price. If one matrix is row matrix, take another matrix is column matrix. Here the cost of one chemistry book is 80 rupees, 80 rupees, 60 rupees and 40 rupees. So 80, 60, 40. So therefore the amount received by the bookseller is matrix multiplication, that is A into B. So therefore your amount by the bookseller is equal to matrix multiplication A into B. Here what is matrix A? Matrix A is 120, 96, 120 into matrix B is 80, 60, 40. So here sum of the product of first row with first column. So 12 8s are 9600 plus 96 into 60. So 96 into 60. So 6 6 are 36, 57. So 5760 plus 120 into 40. So 4800. So that is 9600 plus 5760 plus 4800. So that is 06 1. So 5 10. So 20. So 20,160. So therefore this total sum is 20,160. So therefore amount received, amount received by the bookseller is 20,160. So using matrix algebra. So this is the method to find the total amount received by the bookseller. So this is the procedure. So next we discuss transpose of a matrix.